What's up? I'm Vin, and I'm going through the June 2024 Geometry Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first, we're going to go through the part 1 multiple choice questions. There's 24 questions here, and each one is worth 2 credits. Question 1, in the diagram below, triangle Brie is the image of triangle Joe after a translation. Triangle Cat is the image of triangle Brie after a line reflection, and we want to know which statement is always true. So for this one here, we have to know that a translation and a line reflection, these transformations are rigid motions, which tell us that if we send a triangle through those transformations, the resulting triangles are going to be congruent to the original. So if we look first, triangle Brie is the image of triangle Joe after a translation. That means we're starting here and we're going to slide this triangle up to here. So notice that angle J would correspond to angle B. Angle O would correspond to angle R, and angle E would correspond to angle I. Okay, so these are the angles that would be congruent here. And one way to see this is that the letter J is in the first position and the letter B is in the first position. So that's how I know those two angles are going to match up. But then next, to get from this triangle Brie to triangle Cat, we're going with a line reflection here. So just imagine we have some mirror line like this, and this triangle is flipping over to this one. So if I flips over, it's going to land on T. And if R flips over, it's going to land on A. And if B flips over, it's going to land on C. So now we could just go through the answer choices. Is angle R always congruent to angle T? Well, no. Look at angle R over here. It has 2 notches, and angle T has 3 notches. So unless these triangles are all equilateral, this is not always going to be true. So 1 is out. Angle J is congruent to angle A. This has a single mark and this has a double mark. Angle J would always be congruent to angle C, but not angle A, so 2 is out. And now we look here, JE is this side here between the single and triple. And if I look over at this triangle over here, the RI has a double and a triple. So this one is not going to always match up with what we have here. I could say that JE is always congruent to BI, and BI is always congruent to TC over here like this, or I could say CT. So this one is not the case. So now I look to the last answer choice. It has to be this one, but let's see why. OE is between the double and triple notch here. So if I put a double mark here like this, then over here, if I translate, that's going to correspond to RI. And when we reflect over this line, that's going to correspond to TA or AT. So now let's look at this. Is OE, this side over here, going to be congruent to AT? Yes, because they both have that double mark here. And notice it's between the 2 angles with the double and the triple marks here. So that's how I know these two are definitely always going to be congruent. Choice 4 is our answer. Question 2, a right cylinder is cut parallel to its base. The shape of this cross section is A, and we have these 4 answer choices to choose from. So for this question here, we need a little bit of an imagination. And what we could do is we could just draw out a cylinder like this, or just imagine a cylinder. And if we're cutting it parallel to the base, the way I've drawn this, the base is going to be here at the bottom where the circle is. If I'm going parallel to the base, I just imagine slicing it like this. And which shape are we going to be looking at on the inside here? We're going to be looking at a circle. Okay, so that's how I know here. Choice 2 is our answer. If we were cutting it perpendicular to the base would result in a rectangle. Okay, so if we slice it vertically like this, and then we open up the cylinder, we would be looking at a rectangle. So 4 is tempting, but that would be if this was perpendicular. The imagery I like to go with here is I just pretend that I'm at a deli and that I'm watching them slice either, a deli meat or some sort of cheese here. And I'm thinking of the slice itself, like a single slice of deli meat or deli cheese. So I don't know, this could be like, cheese or bologna or something. And the slices here are just the individual slices. So choice 2 is our answer. Question 3, what is the minimum number of degrees that a regular hexagon must rotate about its center to carry onto itself? So for this one here, if you just want to have a formula to use, we're going to take 360 and we're going to divide it by the number of sides in a hexagon. And a hexagon has 6 sides. So if we do 360 divided by 6, that's going to give us 60. So the minimum degrees that we would need to rotate to carry the hexagon onto itself would be 60 degrees. But if we want to see the concept here, just imagine that we have this regular hexagon. All the sides are equal and all of the angles here are equal. And I'm going to draw in lines like this going towards the center of the hexagon. Okay, so this is just going to represent the center of rotation here because the rotation is happening about the center. So if we see here, what's actually happening is a full circle is 360 degrees. But since the hexagon has 6 sides, it's going to have 6 vertices or points at the end. So that's why we're doing 360 divided by 6, is we want to see what the degree measure of each of these angles here is. And if we spin 60 degrees, let's say starting in this position, that would send this vertex over here to this one, and so on and so forth. It would just go like this all the way around, and the hexagon would be facing the same direction that it started with. Okay, so if we have any multiple of 60, that would carry the hexagon onto itself, but we want to know the minimum number. That's why we're just doing the first one here when we do 360 divided by 6. Choice 3 is our answer. Question 4, in the diagram below, a sphere is inscribed inside a cube. The cube has edge lengths of 18, and we want to know what is the volume of the sphere in terms of pi. So for this one here, we're going to use the formula for the volume of a sphere, which is 4/3 pi r cubed. And now we have to look at this sphere on the inside. They told us that the cube has edge lengths of 18. So what that tells us is that the distance across in any direction is going to be 18, as long as we're going in a direction that's perpendicular to two opposite sides like this. So let's say I take this location over here and I go all the way across. You see how this is forming the diameter of the sphere, and the diameter of the sphere is going to be 18 units. Okay, so that's going to be our diameter, which tells us the radius, if we divide this by 2, is going to be 9. Okay, so that's the information we need. When they say the sphere is inscribed inside the cube, that means that they're fitting in the biggest sphere possible, and it's tangent or touching at one location the 6 faces of the cube. So now I just plug in r equals 9 to the formula for the volume of the sphere, and we have 4/3 pi and then times 9 to the 3rd power. So on the calculator, just know for the Geometry Regents that you should be in degree mode for the whole test. So I'll just do that in the beginning here. And what we're going to do is we're just going to type in 4/3. And for this one, I could just write 4 divided by 3, or I could press alpha y equals enter to pull up a blank fraction. This is a useful technique, especially if you have to type in a complicated fraction on the calculator. So I have 4/3, and then I have pi as second and the up arrow here, and then I have 9 to the 3rd power. The only thing that I don't like about what I've typed in so far is that this is not going to put my answer in terms of pi, and all of the answer choices are in terms of pi. And you might say, oh no, which one's my answer? You can type in all of the answer choices, or what you could do is you could just leave the pi out. Okay, so I'm just going to plug in without the pi, and that's going to tell us what the coefficient of pi is. So 972 times pi, and we could just double check. If we do 972 pi, we'll see that it matches the decimal value that we have above. So 972 pi, choice 3 is our answer. So the volume here is simplified to 972 pi. We're going with choice 3. Question 5, in the diagram below, EM intersects HA at point J. EA is perpendicular to HA, so I'll just mark this over here. Then we have EM is perpendicular to HM, so I can mark these two as perpendicular. And then we have if EA is equal to 7.2, so now I'm just going to label, EJ is 9, AJ is 5.4, and HM is 3.29. What is the length of MJ? So I'm going to put an X here to the nearest hundredth. So for this one, we have to use concepts of similar triangles. Just know similar triangles is a massive part of the Geometry Regents. This is like 30 to 40% of the test. You have to know about similar triangles and how to set up proportions with the corresponding sides. So here we were told that these two angles are right angles, but notice we were told that these two line segments intersect at point J. We have EM intersects HA at J, which tells us that these two angles here are congruent. These are vertical angles. So now I know that these two triangles are similar by angle-angle similarity. Notice that they have two pairs of congruent angles. So now we're going to set up a proportion, but notice that they gave us 3 sides of this triangle and just 1 side of this triangle. They did that to make it challenging to see if we know which sides are corresponding. So the way that I like to identify the corresponding sides is I pay attention to the angles. Notice that we have this vertical angle marked here. Like, we have two of these angles here are vertical angles, but one of them is marked here, and the 90-degree angle is marked here. So I would know that these two sides that I just highlighted are corresponding because they're between the same two congruent angles. Notice like we have the vertical and the right angle. So I'm going to mark it off in both triangles. And then what we would have next is the shorter side here is going from the 90-degree angle to this far angle over here. If I want to mark this with, let's say, a double notch like this, then I could say that EA over here, so this side corresponds to HM. So once again, the angles are what give it away from me, that I have the double mark and the right angle. So the double mark and the right angle correspond over here. So now when I set up the proportion, I'm going to say, let's say in the big triangle, 7.2 over 5.4. I'm going to set that equal to 3.29 over x. Okay, and notice the consistency here, that I went from the double to the 90 to the single. So then I went from the double to the 90 to the single when I set up my second ratio. And now I just have to cross multiply here. So I'm going to have 7.2 times x equals, and for the rest, we'll use the calculator. So we're going to do 5.4 times 3.29. And this is equal to, down here, we have 7.2x. So I'm just going to divide this now by 7.2, just so we don't have to flip back and forth between screens here. So this is going to be our value of x. So I'll just show the rest of the work. When we do 5.4 times 3.29, we get 17.766. And then to solve for x, we divide by 7.2 on both sides. And then we could write out our value of x here. X is equal to 2.4675. But we are rounding to the nearest hundredth. So looking here at the hundredth place is a 6. To the right is a 7. So we're going to round this up to 2.47. So choice 1 is our answer. Question 6, which equation represents the line that passes through the point 2, -7 and is perpendicular to the line whose equation is given here? So one thing to know about perpendicular lines is that their slopes are opposite reciprocals of each other. So what I would do here is find the slope of the given line, and the slope of this given line is 3/4. That's our coefficient of x. And then the perpendicular slope that we're going to go with is the opposite reciprocal of 3/4. So what we mean by opposite reciprocal is we change the sign. So if the number is positive, we're going to make it negative, and then we flip to get -4/3 altogether. So just looking at the answer choices, you see how the last two have the slope of -4/3? That means those are the only possibilities here. These two lines that are expressed here would be parallel to the original line. So that's why these two answer choices we could just chop out. So now the formula I want to use is y minus y1 equals m times x minus x1. This is the point slope form equation of a line. So now let's think about what the question was asking us to do. They want the equation of the line that passes through this point. So this is going to be our x1, y1 and is perpendicular to this line. So we're going to use this perpendicular slope, and this point is our x1, y1, and plug in. So we're going to have y minus y1 is -7. So I could write minus -7, or I could just change this to a +7. So I have y plus 7 equals the slope m is going to go in front. We have -4/3. And then we have x minus x1 is equal to 2. So we're looking for y plus 7 equals -4/3 x minus 2. And this matches up with choice 3. If you want to use the calculator for a question like this, what you could do is go to the y equals, and you could type in 3/4 x and then +4. So that's the original line. And then you could just run through all of the answer choices. But the thing is, you'd have to solve them for y. So let's say choice 3. I want to show why this is good. I write in -4/3, and then parentheses, we have x minus 2. And then if I solve that equation for y, I would subtract 7 on both sides. So now here, I'm just going to do -7. And let's see what we get. We get these two lines that are perpendicular. And I just want to see if the point 2, -7 is on the second line. And notice here, when x equals 2, y is equal to -7. Okay, so you could do that for all of the answer choices to see which one is which, or you could just do the algebra. Either way, you're going to get choice 3. Question 7, in triangle RHM below, the measure of angle R is 110 degrees, and the measure of angle M is 40 degrees. And then we have if triangle RHM is reflected over side HM. So I'm just going to highlight this side over here. So we're going to be reflecting the triangle over this side. to form quadrilateral RHR prime M, which statement is always true? So what I'm imagining here is if we reflect this over, let's say R prime is going to be at about this location here. So I'm just treating this line here as the mirror line. And now I'm going to just connect these points like this to form the quadrilateral that we're talking about in this question. All right. You should bring a straight edge to the test, a ruler. Otherwise, hopefully they have one for you to borrow. Or if you don't and you just want to improvise, you could just use a student ID or something that, acts as like a decent, ruler for questions like this. So now what I would do before I start answering anything is use the idea that reflections are rigid motions. So that means in this triangle over here, this angle would be 110 degrees. This one over here would be 40 degrees. And also, no, inside of a triangle, the sum of the three angles makes 180. So if I do 110, just make this a little neater. So if I do 110 plus 40, so I add these two, we'll get 150. And let me just fix this. So we'll make this a little bit neater. So 150. Then we do 180 minus 150. That tells us the missing angle is 30 degrees over here. Okay, so this angle will be 30, and so would this one. So now let's see. Quadrilateral RHR prime M is a parallelogram. That is not the case. I mean, I think you just look at this here and see that the opposite sides are not parallel. What also gives it away is that this angle over here in total is 80 degrees. So yeah, this angle over here, if I did 40 plus 40 is 80, and this one 30 plus 30 is 60. So in a parallelogram, the opposite angles have to be congruent, both pairs, and these are not. Okay, so this is not a parallelogram. Let's see next. The measure of angle MHR prime, so that's this angle over here. So we're focusing on this angle now, is 40 degrees, which is not true. It's 30 degrees. So this one is out. And then let's see. The next angle they want us to think about is the measure of angle HMR prime is 40. So this one is looking good. Okay, the measure of angle HMR prime is 40. This is looking good, but let's see why the other answers, or the other answer choice here, 4, is no good. So MR is this one over here, is congruent to HR prime. No, if this were a parallelogram, then we could say for sure the opposite sides are congruent, but this is not always going to be true here. This one is no good. If they said MR is congruent to MR prime, then yes, but 4 is no good. 3 is definitely our answer. Question 8, the funnel shown below can be used to decorate cookies with melted chocolate. The funnel can be modeled by a cone whose radius is 6 centimeters and height is 13 centimeters. The baker uses 2 cubic centimeters of chocolate to decorate each cookie. When the funnel is completely filled, what is the maximum number of cookies that can be decorated with the melted chocolate? So for this one, the funnel is being modeled by a cone. So first we need to know the formula for the volume of a cone, which is 1/3 pi r squared times h. And this formula is on the reference page. So what we have here is the radius of this cone is 6 centimeters. So just make this a little neater. So we have the radius is 6 centimeters and the height is 13 centimeters. And then the next important thing they told us is that the baker is going to use 2 cubic centimeters of chocolate for each cookie. Okay, so 2 cubic centimeters of chocolate will get you 1 cookie. So that is going to be very important in a moment. So first I would just plug into this formula. We have 1/3 pi, and then we have the radius is 6 centimeters. Now, on the Regents, you do not have to write units in your answers to get full credit. But for questions like this, I think seeing the units actually does help when you actually have to convert and see how many cookies can be made. So here, I'm going to say the radius is 6 centimeters, and it's being squared times the height is 13 centimeters. So from here, what's going to happen is when we do centimeters squared, we're going to have square centimeters. But then times centimeters to the first is going to give us cubic centimeters. So now we just have to worry about the number here. So we go on the main screen and we could write in, we have 1/3 times pi. So I'm just going to write pi is second in the up arrow. We have 6 squared. So I could write the square outside or inside, it doesn't matter. And then times 13. And then this is going to be the volume of the cone. Now, eventually we're going to have to divide this by 2. So I'll just do this all at once here. And then I'll use this to get to our final answer. So the volume worked out to just about 490 cubic centimeters. And then what we have next is remember, 2 cubic centimeters of chocolate is used to make 1 cookie. So then we could just take the 490 cubic centimeters and we can multiply by 1 cookie. So I'll just say 1 cookie for every 2 cubic centimeters. So that's why on the calculator I divided by 2. The units here cancel out, and we're doing 490 divided by 2 is 245. So we have 245 cookies. Okay, so me personally, once again, they don't make you include units in the free response part of the test. That's not part of the scoring. But I believe when you do write the units in, it makes more sense as to why we're dividing by 2. You could see the units cancel out. So in this case here, 245 cookies. Choice 2 is our answer. Question 9, in circle O below, chords CT and BN intersect at point A. Chords CB and NT are drawn, and we want to know which statement is always true. So for questions like this, when you have intersecting chords and then they draw in another pair of chords to make 2 triangles, these 2 triangles are similar. The reason being is when we have the intersecting chords, we could say that these angles over here are congruent because they're vertical angles. But then if we focus on, let's say, this arc over here, arc CN, notice that this angle over here at B is intercepting this arc. So the measure of this angle over here is half the measure of this arc. So I'm just going to put a double mark here. But notice that angle T also intercepts this arc over here. And T is also an inscribed angle. So when two inscribed angles intercept the same arc, those inscribed angles are congruent. Okay, because if I put, let's say, like a 2x here, then this would be half, and I would put an x here, and I could put an x here, so those 2 angles would be equal in measure. So now that I have these 2 triangles have 2 pairs of congruent angles, they are similar by angle-angle similarity. And then we could also argue here that this angle is congruent to this angle over here. So now let's go through the answer choices. So we have NT over TA. And what I think about when I look at this proportion in the first triangle over here is from NT to TA is going from the triple to the double to the single. So I'm just thinking 3, 2, 1. I'm just walking along the angles here. So when I look at the next ratio, it has to do the same exact angle walk. It has to go from the triple to the double to the single mark. So notice we have CB over BA. Right away, this one is looking good. So when your first answer choice looks good, you should absolutely go through the others to see why they're no good. Okay, because notice if I go 3, 2, 1, in the next triangle here, I go from C to B and then from B to A. So this one is already looking good. Well, let's see. Angle BAC, that's this angle over here, is congruent to angle ATN. But notice that this angle over here should be congruent to angle NAT or TAN. Not necessarily this one. We want the answer that's always true. So this angle is not necessarily always going to match this angle over here. That's why 2 is out. And now we have another proportion. So we have NA over AB. So NA over AB, the problem with this is NA is comparing the triple and the single mark here. Notice that this is the side between the triple and the single. But then AB is connecting the double and the single. So right away, I could see that they're not comparing the corresponding sides in both triangles here. If I'm focusing on this side, so let's say I just color code this for a second. Side NA would correspond to side CA in this triangle. So if they had said NA over CA, then this is looking good. So that's why this answer choice is out. And then we have the measure of angle BCA, that's the one with the triple mark, is congruent to NTA has a double. So the triple and the double do not necessarily have to be the same. So 4 is out. Choice 1 is definitely our answer. Question 10, I want to label this diagram as we read the question here. So we have in the diagram below of triangle ABC, CBF is drawn, and AB bisects angle FBD. So here's angle FBD. And if this line segment bisects it, that means that these 2 angles over here are going to be equal in measure. Then we're told that BD is perpendicular to AC. So that makes these 2 angles over here right angles. So they're both 90 degrees. And then next we have the measure of angle C is 42 degrees. And we want to know what is the measure of angle A. So I'll put an X over here. And this is what we're looking for. If I want to be really fancy, I could say that this is X degrees and that I'm just solving for X. But in the multiple choice, your notation is not really going to matter. But they do use this nice notation later in the test. So from here, what we're going to do is just start finding the missing angles. So this angle is one that we could find because we have a triangle over here and we know two of the angles. So when we want to find the third angle, we just add these two and subtract that sum from 180. So I'm going to do 90 plus 42. And you could use a calculator for this. This is going to work out to 132. And then you subtract 132 from 180. So if we subtract, we get 48. So the missing angle over here is 48 degrees. And now these two angles are equal in measure. So let's say they're y degrees each. So both of these angles are y degrees. That allows us to set up the equation y plus 48 equals 180. Okay, so here I'm just going to solve for the numerical value of y. So we have 2y here because we're doing y plus y. And now we have plus 48 equals 180. And now we solve for y by subtracting 48 on both sides. So here, let me just make that neater. So we have minus 48 on the left and the right. And now we have 2y equals, if you do 180 minus 48, that's going to give you 132. And then divide both sides by 2. And that tells us that the missing angle is 66 degrees. Okay, so this angle over here, I'll get rid of the y now, and I'll just say that this is 66 degrees on the inside. Okay, so 66 here and 66 here. And remember, where I'm getting this from is that we have a straight line here. And a straight line, the sum of the angles building the straight line makes 180. So now that we have this, notice that x here is one of the missing angles inside of this triangle, okay? So this missing angle over here, we could find by doing x plus 66 plus 90 equals 180. And now from here, we could just add these two. We get x plus 156 equals 180. We could have also used the fact that we're in the right triangle and these two angles are complementary. So either way works out fine here. So we'll just solve this one because that's what was set up. And now I have x is equal to 180 minus 156 is 24. So the missing angle over here, I'll just write it in, is 24 degrees. So the measure of angle A is 24 degrees. Choice 1 is our answer. Question 11, in circle O below, OA equals 6 and the measure of angle COA equals 100 degrees. What is the area of the shaded sector? So for this one here, what we're going to have to do is use the formula for the area of the circle. But then we're going to use the concept of part over whole, and we're only going to take a fraction of the total area. So the total area of this circle, if we plug in the radius, we have pi times 6 squared, is going to give us 36 pi. And then what we're going to do is we're going to take the fraction that's shaded. Well, in a full circle, we have 360 degrees. So if that central angle is 100, that tells us that the other angle is 260 degrees. Okay, so this shaded section covers 260 degrees of the total circle. So the total area is 36 pi, but we're only interested in taking 260 out of the total 360. Okay, so this is what we're taking. And then from here, we could use a calculator, or if we want to see some cool math, we could do here. We could chop off the common zeros. And now that would give us 36 pi times 26 over 36. And then we have matching factors. So 36 over 36 cancels. And we're left with 26 times pi, which is 26 pi. And choice 2 is our answer. Question 12, we have a whole lot going on, but for something like this, I highly recommend that you draw this out. So we have rectangle ABCD. So the first thing I'm going to do is draw a rectangle, and I'm going to name it ABCD. Okay, so this is our rectangle. It doesn't have to be drawn to scale. It's just going to help us answer the question. Then we have diagonal AC is drawn in. So I'm just going to draw in AC over here. And we have the measure of angle ACD. So that would be this angle down here is 37 degrees. So this is 37 degrees. And what we have next is the length of BC is 7.6 centimeters, but the answers don't have units at the end, so I'll just write 7.6. And we want to know what is the length of AC. So I'm going to put an X here, and we're going to round to the nearest tenth. So for this one, since we're dealing with a rectangle, the four angles of the rectangle are 90 degrees. So I'm going to put a right angle here and here. And since a rectangle is a parallelogram, the opposite sides are equal in measure. So if this side over here is 7.6, I could say that this side over here is 7.6. So now we're looking for X. We know one side of this right triangle, and we know one of the acute angles on the inside. So now we're going to use trig. Okay, so I'm focusing on this right triangle over here, and we're going to use trig. So the mnemonic I like to use is SOHCAHTOA. So we're going to use SOHCAHTOA. If this is the angle that we're starting with, 37 degrees, notice that across from the 37-degree angle is the 7.6. So this side here is the side opposite of the 37-degree angle. And x is across from the right angle, so this represents the hypotenuse. Okay, so that's where this mnemonic comes in. O stands for opposite, H stands for hypotenuse, and A stands for adjacent. Okay, so we have opposite, hypotenuse, adjacent. Those are the three terms we need to know. This side down here would be adjacent to the 37-degree angle. But since we know the opposite side, so this is where the thought process comes in. We know the opposite side is 7.6. So we know the opposite, and we're trying to find the hypotenuse. We say opposite hypotenuse, which trig function uses opposite and hypotenuse? Sine uses opposite and hypotenuse. So the way we use the sine function is we say sine of the angle, let's say I call it theta, is the ratio of the side opposite of theta over the hypotenuse of the right triangle. So that's what we're going to be using here. We're going to say sine of the 37-degree angle is equal to the side opposite of the 37-degree angle, which is 7.6 units long, over the hypotenuse is x, and that's what we're looking for. Now, if you want to see some cool math here, a little trick is when you're solving for x and it's in the denominator, you could use a technique that one of my coworkers calls the swap. You could just say, oh, x equals 7.6 over sine 37. So if you just want to remember that you could do that, then great. Otherwise, there's no shame in it. You could show the algebra here and just cross multiply. So that would give you, you would have x times sine of 37 degrees is equal to 1 times 7.6 is 7.6. And then from here, if you're solving for x, you're going to divide both sides by sine of 37 degrees. So that's where 7.6 over sine 37 is coming from. Okay, so you can do the algebra, or you could just remember to do the swap. Okay, whatever makes you happier. And now we just type this in. So remember, we should be in degree mode here. We're going to do 7.6 divided by sine of 37 degrees. And now we just press enter. And to the nearest tenth, we're going to get 12.6. So once again, we're rounding to the nearest tenth. And here in the tenth place, we have a 6. To the right is a 2, which is less than 5. So we round down to 12.6. Choice 4 is our answer. Question 13, a peanut butter manufacturer would like to use a cylindrical jar with a volume of 1,180 cubic centimeters. The jar has a height of 10 centimeters. What is the diameter of the jar to the nearest tenth of a centimeter? So for this one, since we're dealing with a cylindrical jar, we're going to use the formula for the volume of a cylinder, which is volume equals pi r squared times h. And then let's write down what they gave us. They told us the volume was 1,180 cubic centimeters. But notice the answer choices don't have units attached, so I'll just write down the numbers here. I'll say volume equals 1180, and then we have the height is 10 centimeters, so I'll just write h equals 10. So we plug into this formula. We have v equals 1,180, and this is going to be equal to pi times r squared times h is equal to 10. So I'm just going to say times 10 over here. And now our goal is to solve for the diameter. The diameter of a cylinder is equal to 2 times the radius. So what we're going to do is we're going to solve for the radius, and then we're just going to double it. We're going to multiply it by 2, and that's going to tell us what the diameter is. So from here, to do the algebra, we want to get rid of times pi and times 10, so we could divide both sides by 10 pi. So what that's going to do on the right is when we do divide by 10, 10 over 10 is going to cancel. And when we divide by pi, pi over pi is going to cancel. And this is going to give us, we're going to have r squared equals, and we're going to have this fraction over here. So now let's just type this in, but be very careful here. I see students do things like this all the time. They do 1180 over 10 pi, and they type it in like this into the calculator. But be careful. This is a very, very dangerous bear trap. What the calculator is reading this as is they're reading it as 1180 divided by 10, and then times pi. So if I did 1180 divided by 10, that's 118. And then if I multiply that by pi, that's going to give me this number here. So the way around it is you could either press alpha y equals enter to pull up a blank fraction, and then just type it in like this, and the calculator will handle this correctly. Okay, then they will divide by 10 times pi. Or what you could do is when you type in 1180 divided by 10 pi, you just put the 10 pi in parentheses, and then the calculator will read this correctly. They'll do 10 times pi and divide that into 1180, okay? And notice then we get the same answer here. But remember, 1180 over 10 pi was equal to r squared, so then I would have to take the square root of that number, and that would tell us what the radius is here. And then ultimately, we're looking for the diameter, so then I would have to multiply that answer by 2. So now we'll just write this out, but just know that if we're rounding to the nearest tenth, we don't have to write out all of these digits, especially since we're in the multiple choice here. So r squared, I'll just say, is 37.56. And then when we take the square root of this, we're going to get roughly here r equals, I'll just say 6.13. I'll round to the nearest hundredth. And then at the end, I'll round to the nearest tenth. So then the diameter, if we multiply this by 2, would work out to 12.26. But then rounded to the nearest tenth, I would just say the diameter here is roughly 12.3. And this is going to match up with choice 4. Question 14, triangle KLM is dilated by a scale factor of 3 to map onto triangle DRS. And we want to know which statement is not always true. So for this one here, I'll draw something out to help us visualize what's going on. So let's say I call this over here triangle KLM. So this is triangle KLM. And then what I'm going to do is I'm going to draw this triangle but 3 times the size. So I'm just going to go here like this and just a rough estimate here of what's actually happening. So this is going to be triangle, let's see, DRS. So if I went KLM, then I have to go DRS. The letters have to correspond here. And we could see the way I drew this that this is roughly triple in size here. So now let's go through the answer choices. Angle K is congruent to angle D. This one is always true. We want the one that's not always true. The reason why this one is always true is that when you dilate triangles, the two triangles are similar, which means the corresponding angles are congruent. And these two angles definitely correspond. So this one is out. And then we have KM is equal to 1/3 the length of DS, which makes sense because if we're doing a scale factor of 3 here, that means we are tripling each side. So if I take this side over here and I take 1/3 of it, that would bring me back to the original amount. Like let's say this side over here was 4 and we scale it by a scale factor of 3 and we get 12. If I multiply this by 1/3, it brings me right back to 4. So that answer choice is definitely always true. So 2 we could eliminate because we want the one that's not always true. So the culprit here is going to be choice 3. The area of the new triangle is 3 times the area of the original triangle. This one here is not the case, and I'll show why in a moment. But first we'll see why is 4 always true. The perimeter of DRS is 3 times the perimeter of KLM. This one is always true because if I triple all of the sides, it's going to triple the perimeter. Like before I had, like, let's say I write here like 3, 4, and then I call this side over here, let's say 6. If I triple each side, then I would have 9, and then 4 times 3 is 12, and 6 times 3 is 18. The perimeter of the first triangle over here, if I add these up, is 13, and the perimeter of the second triangle over here, if I add these up, I get 39. And notice that if I triple 13, it gives me 39. So this one here is always true. But now let's investigate why choice 3 is definitely not true. So I want to start off with the new triangle here, and this could represent triangle KLM. And now let's say I extend each of these sides here like this. So I'm going to extend this one out, and I'm going to extend this one out. And I'm going to just try to draw this as precisely as possible. So this side over here, you can see is this long. So if I go here and then I go here, this is going to represent me tripling the original side. And then I'm going to do the same thing over here. So I'm going to mark this over here, and then I'm going to mark this over here. So our new triangle is going to be this big triangle here that I just drew in. But now watch what happens when I extend all of this stuff across and I connect the points. So here I'm going across like this. I'm going to make it parallel to this side, and the same thing over here. So I'm going to do this. And over here, notice that it's hitting this third side of the triangle, breaking it into thirds. So now what I'm going to do is I'm going to start connecting these points. So I'm going to go and I'm going to mark this off. So now if we name this little triangle over here, triangle KLM, and then we name the big triangle here, triangle DRS, we could see that triangle DRS, the big one, has 1, 2, 3, 4, 5, 6, 7, 8, 9 of the little triangles that represent triangle KLM. So the area of triangle DRS is actually 9 times the area of triangle KLM. And the reasoning behind this, if you look at the formula for the area of a triangle, 1/2 base times height, if you were to triple using a scale factor of 3, you triple the length of the base and you triple the length of the height of the triangle. Notice that this is going to give us a 3 times 3 equals 9. So it's going to be 9 times 1/2 base times height. Okay, so this multiplies the area by 9. So that's why 3 is definitely not true. Choice 3 is our solution. Question 15, a rectangle with dimensions of 4 feet by 7 feet is continuously rotated about one of its 4-foot sides. The resulting 3-dimensional object is and we have these 4 options to choose from. So for this one, I would just draw out a rectangle. So we have a 4 by 7 rectangle. So we'll call this side 4 units long and this side 7 units long. And we are rotating it continuously about one of its 4-foot sides. So that means the axis of revolution is going to be on the 4-foot side. So if we rotate this rectangle going in this direction here and we spin it around, what shape would we be looking at? We would be looking at a cylinder. Okay, so what I'm imagining here is a cylinder, and it's going to look something like this. Okay, so there is our cylinder. But what we have to be able to do is see this shape inside of the cylinder. So the axis is going through the center of the cylinder like this. So the original rectangle, I'm just kind of seeing it off to the side like this. So here's the original rectangle inside of the cylinder. And when it rotates around, you see how this side here is 7, this side is 4. 7 represents the radius of the cylinder, and 4 represents the height of the cylinder. So we're dealing with the cylinder, which eliminates choices 3 and 4. And the cylinder, the radius is 7 and the height is 4. So that tells us it's going to be choice 2 and not choice 1. If we wanted to get a cone by rotating, we would have to rotate a right triangle. So if we had rotated a right triangle that was a 4 by 7, then the last 2 answer choices would be in the running here. But that's not the case. Our answer here is going to be choice 2. Question 16, we have all of this information, but we do not have a diagram. So for this one, I would draw it out. We have right triangle ABC. Altitude CD is drawn to hypotenuse AB. So for these type of questions here, I personally like to put the right angle over here at the top. So I would draw my right triangle like this going this way. And I want the right angle at the top. And I want the hypotenuse to be facing in this direction here, going horizontal. So there's the right angle. And they're telling us that the altitude is being dropped down from the right angle to the hypotenuse. So I'm going to draw the altitude down like this. And this is going to be point D. So now we could label. We have AD is equal to 4. We have CD is equal to 8. So that's the altitude. And we're looking for BD, which is this piece over here. So if you want a nice formula to use, we could call this part 1 of the hypotenuse. So this is part 1. And then this piece over here is part 2. And this formula is pretty nice to use. We have part 1 of the hypotenuse of the big right triangle over the altitude is equal to, so we're just abbreviating here, is equal to the length of the altitude over the other part, so over part 2. So this, I just plug into the formula. I have 4 over 8 equals 8 over part 2 is x. And now we cross multiply. So we're going to have 4x equals 8 times 8 is 64. And then divide both sides by 4. And x is equal to 16 divided by 4. I'm sorry, 64 divided by 4 is 16. Okay, so that is our solution here, 16. Now, before we move on, I want to show another way of doing this. If you forget this formula, then what you would do is you would take this triangle over here and you would draw it separate. So you would draw it outside of the diagram like this. And the short side is 4 and the long side is 8. So that would put A over here, that would put D over here, and that would put C over here. Okay, so I'm just, once again, taking this triangle, pulling it out over here and rotating it so that the longer leg is on the bottom and the shorter leg is going this way. So then if we set up the proportion, I have the short leg is 4 over the long leg is 8, would have to equal the short leg is 8 over the long leg in this triangle is x. Anytime you have a right triangle and you drop the altitude down to the hypotenuse, that generates 3 similar triangles, which allows you to set up these proportions here. Okay, so this is the alternate approach, and it gives us the same exact proportion, which will give us the same answer, x equals 16. So the length of BD is 16. Choice 4 is our answer. Question 17, if ABCD is a parallelogram, which additional information is sufficient to prove that ABCD is a rectangle? So I'm going to draw some parallelogram over here, and then I'm going to draw a rectangle next to it. So here's a parallelogram. I'm just trying to make that a little bit neater. So there's the parallelogram sketch. And now here is a rectangle on the side over here. So for this one, if you just know the properties of a rectangle and parallelogram, then you could probably answer this very quickly. But let's say you forget. Then drawing something somewhat to scale is your best option to go through the answer choices. So let's say I call this one ABCD, and I call this the exact same thing, ABCD. And then you just go through the answer choices to see which one it has to be. So if you could show AB is congruent to BC, that the consecutive sides here are congruent, is that enough to show that it's a rectangle? Well, no, because in a rectangle, the consecutive sides do not have to be congruent. That would be enough information to show that the parallelogram is a rhombus, but that's not going to be enough to show that it's a rectangle, okay? So that is not our answer here. So let's move on. AB is parallel to CD. Well, that's true because this is a parallelogram. The opposite sides have to be parallel. So that's not additional information. That's just going to be a result of ABCD being a parallelogram. So that is not our answer. Then we have AC is congruent to BD. Well, let's think about what AC represents. AC is a diagonal and BD is also a diagonal. So in a rectangle, the diagonals are congruent. So choice 3 is definitely our answer. But why is choice 4 no good? Why is it not enough to show AC is perpendicular to BD? Well, for one, you could see here that these diagonals are not perpendicular. So that's not something that would make this a rectangle. That would be enough to prove that the parallelogram is a rhombus. Okay, so this would be the case if we were trying to show the parallelogram is a rhombus. If I drew out a parallelogram where all 4 sides were equal in measure, so I'll try to draw this as best as I can, we could see here that when I draw in the diagonals, and let me just make this a little bit neater. So let me try one more time. So here is the first diagonal, and here is the second diagonal. So we could see here, this one's like definitely a little bit better, that these are going to form 90-degree angles. If I had drawn a better rhombus, it would clearly be 90 degrees. Okay, so 4 is out. Choice 3 is definitely our answer. One more thing before we move on is that there could be a 5th answer choice that would work. If we had showed that a pair of consecutive sides were perpendicular, let's say we were able to show that AB was perpendicular to, let's say, AD, then that would tell us that we have a right angle, and a parallelogram with a right angle is a rectangle. So this would also work, but that's not what was included here. Question 18, I'm going to show how to do 2 ways. I'll show how to do this with the graph paper they give you on the back of the test, and I'll also show you how to just use a formula here. So if we do this the visual way, what I would do is just use a straight edge to make an XY axis. And remember, this is the paper on the back of the test that you could actually tear out. So this we could use to make a graph to help us answer the question. So A is located at negative 5, 4. So that's left 1, 2, 3, 4, 5, and up 1, 2, 3, 4. So here's point A. And then point B is located at 7, negative 4. So that's 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4. So here is point B. And what they're asking us for here is the coordinates of point P that separates this line segment over here into a ratio of 1 to 3. So what I'm imagining here for this question is some line segment. And what's going to happen is it's going to be broken into a ratio of 1 to 3, which means that it's going to have 4 equal parts. So the location of point P would be somewhere over here if this were a horizontal line. Okay, and just see what I've drawn over here, that P is located over here. And notice that I have 1 equal part here, and I have 3 equal parts to the right. So that's what's going to happen. If it's a ratio of 1 to 3, it's going to be a total of 1 plus 3, or 4 equal parts. And so these are the 4 equal parts, 1 to the left of P, 3 to the right of P. So how do we determine that by the graph? Well, for this method I like to call the rise over run method. How do you get from A to B? Well, to get from 4 to negative 4, so if I'm going from a height of 4 down to a height of negative 4, I'm going down 8. I could actually count the boxes. I could count 1, 2, 3, 4, 5, 6, 7, 8. or I could just do the subtraction here. And now I'm going to go from -5 to 7, which is going to be a run of 12. So I'm going to go over 12. I could count the boxes to get there. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I could just do 7 minus -5 is 12. And now if we're breaking this into 4 equal parts, so this is 4 equal parts, I'm just going to divide that rise and run by 4. So I'm going to divide this by 4. And now I'll write out 8 divided by 4 is 2. So that would be going down 2. And 12 divided by 4 is 3. So watch what happens. I'm going to go down 2 to the right 3. And I'm going to start at point A. So we go down 1, 2 and over 1, 2, 3. And then we go down 1, 2 over 1, 2, 3. We go down 1, 2 and over 1, 2, 3. And if I do it one more time, down 2 over 3, it brings me to the end at point B. And notice now I've broken this line segment into 4 equal parts. And P is going to be located over here because I'm going to have 1 congruent part to the left of P and 3 congruent parts to the right. And now I just have to identify the coordinates of P. P is located at -2, 2. Okay, so this point over here is at -2, 2. And this tells us that choice 1 is our answer. So now here's option 2. And option 2 is easier to use, but it's harder to remember this formula. So for this one, I want to find my new x-coordinate for point P. The x-coordinate is equal to x1 plus P over P plus Q times x2 minus x1. And I'll explain what each of these pieces mean. So for this, x1, y1 represents the point that's more to the left. So A is going to be our x1, y1. And then B is the point more to the right. So that's going to be x2, y2. And then P and Q are the parts of the ratio. So P is the first part of the ratio and Q is the second part of the ratio. So if I plug into this formula, I'm going to have x equals, and I take x1, the x value more to the left, which is -5, and I'm going to have -5 plus P is equal to 1, so that's going in the numerator. And if I do P plus Q, 1 plus 3 is equal to 4. And now I'm doing x2 minus x1. 7 minus -5 is going to go here. So I have 7 minus -5. And now I simplify this. I have -5 plus 1/4 of 7 plus 5 is equal to 12. And now I have 12 divided by 4 is 3, and -5 plus 3 is -2. So this is going to give me my x value, and this is the only answer that has x equals -2. I want to find my y value, so if I want to find my y value using this formula, then I just swap everything out and say y equals y1 plus p over p plus q, and then this gets multiplied by y2 minus y1. Okay, so it's basically the same formula, but we just swap out the x's and y's. So if I want to double check just to make sure this gives me the right y value, I have y equals y1 is 4 plus p over p plus q is still 1/4 times y2 minus y1. I get -4 minus 4. And for this one, I would have y equals 4 plus 1/4 of -4 minus 4 is -8. So here I would have -8 divided by 4 is -2, and 4 minus 2 is equal to 2. So notice that the y value does match when we use the formula. But that's up for you to decide. The advantage to the formula is that you will get it right every single time. The graph, the limitation is if you land on a decimal value. I've seen that happen one year for the Regents. It's a lot more challenging when you have to deal with decimals. But if you get the concept really does help explain why the formula itself works. So I think these are both nice to know because they reinforce each other. Question 19, in the diagram below, AB and CD intersect at E, and CA and DB are drawn. If CA is parallel to BD, which statement is always true? So for this one here, we have intersecting line segments. So right away, we could say that these two angles are congruent because they're vertical angles. And then when we're told that these two line segments are parallel, that tells us then that these angles here, these alternate interior angles formed, are congruent. So I'm going to mark C congruent to angle D over here. So these two angles are congruent. And now these two triangles are similar by angle-angle similarity. So that tells us the last pair of angles are also congruent. So I'm going to put a triple mark here to say angle A is congruent to angle B. Now, which statement is always true? These two triangles here look like they're congruent, but they don't necessarily have to be congruent. They didn't tell us anything about, let's say, E being a midpoint or anything like that. We only know that the angles are congruent. So all we could say here is that these two triangles are similar. So right away I could see, all right, well, if the triangles are similar, it has to be this. But then why are the other answer choices no good? Well, like I just said before, AE congruent to BE, these two line segments here are corresponding in both similar triangles, but corresponding parts of similar triangles are not necessarily congruent. The corresponding angles in similar triangles are congruent, but the sides don't have to be the same length. So one is out. CA and DB, they are definitely corresponding sides, but these two triangles do not necessarily have to be congruent. So 2 is out. And then these two triangles do not have to be congruent here, so 4 is out. So 3 is definitely our answer. Question 20, if sine of 3x plus 9 degrees equals cosine of 5x minus 7 degrees, what is the value of x? So for this question here, it helps to know that sine and cosine are cofunctions. And what that means is when we take a pair of complementary angles and we plug one of them into sine and one of them into cosine, then those two values are going to be equal. So what we could draw from this is that this angle over here and this angle over here are complementary. Okay, so these are complementary angles, which tells us that they add up to 90 degrees. So we could say that 3x plus 9 plus 5x minus 7 is going to be equal to 90. So now we just have to do the algebra here. So 3x plus 5x is 8x. And then we have 9 minus 7 is 2. And this is equal to 90. And then from here, we just subtract 2 on both sides. And what we have is we have 8x is equal to 90 minus 2 is 88. And then just divide both sides by 8. And this tells us x is equal to 11. So the value of x would be 11. Now, just to highlight that concept a little bit more, I have, let's say, sine of 70. Which angle is complementary to 70 degrees? That would be 20 degrees, because 70 plus 20 makes 90. So if I did cosine of the complement of 70, notice that I get the same exact ratio here. So that's the concept that was used to set up the equation. But we do get a calculator at the Regents. So if you wanted to go through the answer choices one by one, let's say I went with choice 1. I said sine of 3 times x, we're going to claim is the wrong answer, 8, plus 9, and I get this value over here. And then I do cosine of 5 times, I'm going to say x is 8, the wrong answer, and then we have minus 7 attached. Notice that my ratios here do not match. But if I were to set this up with the correct value here, so I plug in 11 instead, so I'm just going to replace the 8 over here with 11, and then I'll just tack on the plus 9. So I have this, and then I have cosine instead of 5 times 11 minus 7. So I'm just going to replace x equals 8 with x equals 11. Watch what happens here. So when we do this, now we get the match. Okay, see, these ratios do match. So you can just go through the answer choices one by one and just plug it in and do this question by brute force, but the concept is good to know. Question 11, which set of integers could represent the lengths of the sides of an isosceles triangle? And notice for these 4 answer choices, there are 2 numbers in each set that match, but the big idea that we need to know here is the triangle inequality theorem. When you have a triangle with 3 sides here, A, B, C, the sum of the 2 smaller sides has to be greater than the third side. So that's something that we just have to know for a question like this. So if you go through each answer choice, you have to ask yourself for the first one, is 1 plus 1 greater than 3? No, that's not true. So that means 1 is not our answer. Then for the next one, you would ask, is 2 plus 2 greater than 5? No, because 4 is not greater than 5. And now here, is 3 plus 3 greater than 6? It is not. 6 is not greater than itself. And now the last one, is 4 plus 4 greater than 7? Yes, that's true. 8 is greater than 7. So these 3 sides could represent the lengths of an isosceles triangle. Choice 4 is our answer. Question 22, in the diagram shown below, altitude CD is drawn to the hypotenuse of right triangle ABC. Which equation can always be used to find the length of AC? So for this question here, what you really need to be good at is identifying corresponding parts of similar triangles. And I know that we're dealing with similar triangles because we have a right triangle and an altitude was dropped down to the hypotenuse. So what that's going to do is it's going to make 3 similar triangles here. And I can just put in numbers to make this easier. Let's say I call this angle over here 40 degrees and I call this one over here 50 degrees. This is reasonable because this side, this leg looks shorter than this leg. And the larger the angle, the larger the side opposite. So the 50-degree angle is bigger than the 40, so this side is going to be the longer one based on how it's drawn. But this is going to help us go through the answer choices. And now if I have 40 here and 90 here, this missing angle would have to be 50 to make 180 in this triangle. And then here, if I have 50 and 90, this missing angle has to be 40. And this is all looking nice because 50 plus 40 makes 90. When you're picking out random numbers, make sure that they're not the same. I wouldn't pick out, let's say, 45 and 45, because the more symmetry you give this thing, then the more answer choices that will possibly be included here. So now we can move on. And what I want to do is I'm going to draw these three triangles out separately. So I'm going to draw them facing the same way as triangle CDB. So I'm going to draw a triangle CDB over here. So we're going to call this, we have triangle CDB. And for CDB, the 50-degree angle is over here, and the 40-degree angle is at the top. So when I draw this triangle now over here, I'm going to draw it facing the same direction. Okay, so this I'm going to call triangle ADC. Okay, and at angle A, we have 40 degrees, and at angle C, we have 50 degrees. So that's the medium-sized triangle, and now the big triangle is over here, and that's going to be triangle ABC. But A is where the 40-degree angle is. B is where the 50-degree angle is, so B is going to go over here, and C is going to be at the right angle. And I like to do this, once again, so that all the triangles are facing the same direction, and it's easier to set up the proportion correctly. So now let's look at choice 1. AC over CD is equal to CD over AD. The problem with choice 1 is that it's setting up two ratios in the same triangle. If you want to set up a proportion here to solve for the length of AC, you have to include two of the triangles. You can't stay inside the same triangle. And also, if we look, see how AC is the hypotenuse of this triangle, CD is one of the legs, and then CD and AD are both legs. So these are just not corresponding at all. So this is just like, yeah, not a good answer. So let's chop this one out. So 2, we look CD over AC. So CD over AC, if we highlight over here, CD over AC is going to be this one and this one over here. So once again, I drew it separate because it'll make it easier to identify what's going on. So is that equal to AC over AB? So now we're in the big triangle, AC and AB. You see how these sides do not correspond. What we have here is CD is the bottom, and we have AC in this triangle is the hypotenuse. And if we look at the big triangle over here, AC is the side on the left, and AB is the hypotenuse. So this one here is no good because they're not setting up the corresponding sides correctly. This would be correct if they had used, let's say, AD over AC equals AC over AB. Okay, then it would be fine if they had switched it to the left side to side AD, but that's not the case. So 2 is out. And now we look at choice 3. We have AC over CD. So if I look at AC, so I have AC over CD. So I'm comparing this side over here with, let's see, we have CD over BC. So CD over BC is now in the small triangle. So CD over BC. And notice these are not corresponding here. Okay, so these are no good because we have the left side to the hypotenuse, bottom side to the hypotenuse. Okay, so just identifying these once again. AC is the hypotenuse. CD here is the bottom side. So this is the bottom side. And then CD is the side on the left, and BC is the hypotenuse. So this one is really out of whack because the hypotenuse should be in the top position here, and these are not even corresponding. So 3 is not it. So it has to be choice 4, but let's see why. So we'll switch over to purple here. We have AB over AC. So that's the big triangle. AB over AC is equal to AC over AD. So now we're in the medium-sized triangle here. So AC over AD. And notice here's the correspondence we need. AB is the hypotenuse of the big right triangle, and AC is on the left, the way that we drew it. And then AC over here in the medium-sized triangle is the hypotenuse. Over AD is the side on the left. So we set up the hypotenuse over the left equals the hypotenuse over the left. So this one is definitely it. Question 23, which congruent statement is sufficient to prove parallelogram mark is a rhombus? So what makes a rhombus special compared to just any parallelogram? Well, in a rhombus, it has a few distinct properties. The four sides are congruent, and also the diagonals are perpendicular. So that's what separates a rhombus from just any plain parallelogram here. So that's what I'm looking for when I'm investigating this parallelogram mark. So let's see the answer choices now. So MA is congruent to MK. This one I could see right away is good because in a parallelogram, the opposite sides are equal in measure. So if they tell us that a pair of consecutive sides are congruent, MA is congruent to MK, then if I mark these two as congruent and their opposite sides are congruent, that would make all four sides congruent. So this one is already good. But now why is choice 2 no good? I'm going to go through the rest of the answer choices. Well, MA, so I'll highlight this. We have MA is congruent to KR, is not special. For parallelograms, the opposite sides are congruent. So this is true for any parallelogram. The opposite sides are congruent. So this is nothing special. And then we have angle K is congruent to angle A. Well, in a parallelogram, the opposite angles are congruent. So this is nothing special for a rhombus. And then angle R is congruent to angle A. If I had consecutive angles congruent in a parallelogram, that would make this a rectangle. It wouldn't be enough to prove that it's a rhombus here. So that's why 4 is out. So choice 1 is our answer. Question 24, a line whose equation is y equals negative 2x plus 3 is dilated by a scale factor of 4 centered at 0, 3. Which equation represents the image of the line after the dilation? So for a question like this, students might just look at this and go, okay, so I have some line and I'm dilating this line by a scale factor of 4. So they may remember when you dilate a line, the resulting line is parallel to the original line. So then they go, okay, so this line here, the image is going to be parallel to the original, and it's going to move it farther out. So the slope is going to stay the same, but the y-intercept, times 4, so it has to be choice 2. Be careful. Choice 2 is a very dangerous bear trap. I know for a lot of dilation questions, you just scale the y-intercept by the scale factor. But what we have to be careful about here is that if we sketch out the line negative 2x plus 3, so negative 2x plus 3 has a y-intercept of positive 3 and a slope of negative 2. That means it's going down to the right one. But one thing we have to really pay attention to what they told us is they told us the center of dilation was at 0, 3. So anytime you have a center of dilation and it's on the line, then the image is going to be the same exact line, okay? So this is one of those questions that's so easy that it's difficult, that the new line is going to be the same line as the original line. It's not going to be projected out like this. What's really going on here, at least conceptually, what I see, is that if I have just a small piece of the line, let's say I have the line segment here, and I scale out these points, let's say I call this the center, and I scale them out a distance of, let's say I scale it out by, I'll go 4. So I just quadruple this. I go 1, 2, 3. I go out here like this. Now it's 1, 2, 3, 4 times the length. This is the new point, but you see when I connect everything, I'm on the same exact line, okay? So if this is the one here that I'm scaling out to go from, let's say, here to here, I'm still on the same exact line. So the line is not going to change when your center is on the line you're starting with, okay? So just remember that. The center of dilation, if it's on the line and you scale it, the line does not change. So the image is going to be the same line, y equals negative 2x plus 3. So now we're moving on to the part 2 questions. There are 7 questions here, and each one is worth 2 credits. Question 25, in triangle ABC below, the measure of angle C is 90 degrees, AC is 11, and AB is 18. And we need to determine and state the measure of angle A to the nearest degree. So the angle that we're looking for is over here. And we're going to use trig for this. So we have to think, angle A is over here. This side is adjacent to angle A. So this side here is next to or adjacent to angle A. And then this side here is the hypotenuse. Now you might say, wait a minute, 18 is also next to angle A. Why isn't this adjacent? But just know the hypotenuse is always across from the right angle. So this side here is the hypotenuse. So then we have the mnemonic again, SOHCAHTOA, and we're thinking adjacent hypotenuse. So that should make us think of cosine. So now what we have is the cosine of angle A is equal to the ratio of the side adjacent to A over the hypotenuse. So now how do we solve for the measure of angle A? Well, we have to do the opposite of cosine, and the opposite of cosine is cosine inverse. So we're going to do the cosine inverse of the ratio, and that's going to tell us the angle. So we're going to type this into the calculator. So let's type in, we have cosine inverse is second cosine, and then 11 over 18. And now this is going to give us our angle, 52 degrees. So I said the answer was 52 degrees, but I'll just go over the rounding technique. So we're rounding to the nearest degree, so we go to the ones place. To the right is a 3, which is less than 5. So we are rounding this down to 52, and I'll just make this neat. So we have this equals 52 degrees, and this is our solution to question 25. Question 26, use a compass and straight edge to construct an equilateral triangle inscribed in circle A below, and leave all construction marks. So for this construction, what we'll do first is just place any point on the circle, and it doesn't matter where we place the point, we just have to make sure that it goes on the circle itself. And now we can move the compass over to that point, and just to play it safe here, I'm going to measure the distance from this point to the center of the circle. So I'm going to extend the compass in such a way here that it reaches the center, and this is just to show here that I'm fixing the length to a certain amount. And now I'm going to swing an arc above and below so that it hits the circle. And then what I'm going to do from here is I'm going to move the compass to any one of these points, but let's say I move it to this one, and I'm going to keep swinging an arc until I go all the way around the circle. And if I do this right, my last arc should land where this one does. And then let's see what we get. So I'm going to move it over and just continue this process going all the way around the circle like this. So we go around. And we have to leave the construction marks on the page here. So we're just going to keep going around like this. And now one more time. And if we did this right, it should land exactly on top of the other one. So let's just see what we get here. And notice that it does land. But now notice we have 1, 2, 3, 4, 5, 6 points. And we have to construct an equilateral triangle. If we connect to all of them, that's going to make a hexagon, which is not what they want. So what we're going to do is we're going to connect every other point here, and it's going to give us the triangle. Now, how do we know that this is equilateral? Well, we just broke up the circle into 3 equal pieces. So each of these arcs on the outside are 120 degrees. So these inscribed angles here are half of the 120 degrees. So these inscribed angles are 60 degrees each. So here is the equilateral triangle inscribed in circle A. Question 27, quadrilateral deer and its image quadrilateral D prime, E prime, A prime, R prime are graphed on the set of axes below. Describe a sequence of transformations that maps quadrilateral deer onto quadrilateral D prime, E prime, A prime, R prime. So for questions like this, what I like to do is I like to pick one point that corresponds to another point. So D and D prime correspond. And they're telling us here that the image is D prime, E prime, A prime, R prime. So that means we're starting here on this quadrilateral and we have to land here. So always make sure you know which one is which. The image is the one that you are landing on. So that means we have to start here. This is the pre-image. So what I'm noticing right away is that this one goes D, E, A, R if I'm going in a clockwise direction. But if I go clockwise here, I'm not going from D prime to E prime. Everything was flipped, which tells me that at some point we're going to have to reflect. So first, what we could do is we could reflect the quadrilateral deer over the y-axis. And what that's going to do is it's going to get everything facing the same direction that it needs to. Like let's say here, if I reflect point E over the y-axis, it would go 1, 2, 3, 4, 5. So then it would go 1, 2, 3, 4, 5 over this way, and it would land here. So then you see how if I connect these 2 points like this, now what we have is this line segment and this line segment are facing the same direction here. And then the translation is going to directly follow. So we're going to reflect over the y-axis, and then we're going to translate. Let's see, we go over 2. So we're going to the right 2, and we're going down 1, 2, 3, 4, 5, 6, 7. And if I want to double check, let's say I do this point as well. I follow E. I reflect E over the y-axis, and then I go 1, 2, and then I go down 7. 1, 2, 3, 4, 5, 6, 7. And notice I land on E prime. So you can get away with doing this with 1 point, but if you check a second point, then you'll feel really safe that your transformation works. or your sequence of transformations. So here we're reflecting over the y-axis, and then we're translating to the right 2 units and down 7 units. Question 28, in circle P below, tangent AL and secant AKE are drawn. If AK is 12, so I'll just label this over here as 12, and KE is 36, determine and state the length of AL. So I'm just going to put an X over here. So for this one here, we have to know our rules for intersecting secants and then tangents and secants. Now, a fun way to remember this is the wee rule. Okay, and I have to give a shout out to one of my former coworkers who has since retired for teaching me this phrase here. So the wee rule, the way it works, when you have two intersecting secants, the whole segment times the exterior is equal to the whole segment times the exterior. So if I call this, let's say, A, B, C, and I call this, let's say, D and E, then what I would say here is the whole segment would be the entire secant, would be AC, times the exterior is the part outside of the circle, would be BC. And this is equal to, in the other secant, the whole thing is EC. So that would be the whole, times the exterior is DC. So this is what I think of for questions like this. And it also works if you have a tangent and a secant, except with a tangent, the whole thing is on the exterior of the circle. Okay, so here the whole and the exterior are the same. So here I would say X times X is equal to, the whole segment here is equal to 12 plus 36. Okay, so the whole secant is 12 plus the 36, but then I'm multiplying by the part outside of the circle, which is 12 units long. So now I have X times X is X squared, and I'm going to set this equal to 12 plus 36 is 48, and we have 48 times 12. So now the rest I could just type in a calculator. So we have 48 times 12. We're just going to work this out. Gives us 576, and now I could just take the square root of 576, and this is going to work out to 24. So now I'll just show this work. We have X squared is equal to 48 times 12 is 576, and then we take the square root of both sides, and we get X is equal to 24. So they said determine and state the length of AL. So just to play it safe, I'm going to say AL is equal to 24. But if you write the correct work over here and you label AL with X, you should be fine here, but I'm just going to say AL equals 24. Question 29, the equation of a circle is, and we have this equation here, and we need to determine and state the coordinates of the center and the length of the radius of the circle. So starting off with this equation, what I want to do first is I just want to move that constant term to the other side. So the plus 7 over here, I want to move to the right side. So I'm just going to start by going minus 7 to both sides. And then what I'm going to do on the left side is I'm going to group together the X squared and the X term over here, and I'm going to group the Y squared with the Y term over here after it. So I'm going to have X squared plus 8X, and then I'm going to leave a space. So you'll see why I'm leaving a space in a moment. So I'm going to have this, and then I'm going to have plus Y squared minus 6Y, and I'm going to leave another space, equals 0 minus 7. So you are allowed to swap terms around because addition is commutative. So all I did was just switch 8x and y squared because these are attached by addition, so I could just swap these two. So now from here, the technique of completing the square, if you are a little rusty from Algebra 1, what you want to do is you want to identify the b term. You want to take half of it and square it and then add that number to both sides. And this is going to work here because we're leading with an x squared, just a 1x squared, and just a 1y squared. So we're going to have the b term for the x is 8. So I divide it by 2 and I square it. So that's going to give us, just make that a little bit neater. So we're going to have 4 squared is equal to 16. And that's the value I want to add to the left side and the right side. So I'm doing plus 16 on both sides. And now the b term for the y expression is negative 6. So I'm doing negative 6 divided by 2 squared. And that gives us negative 3 squared. And that's equal to positive 9. So I'm going to add 9 to both sides. And this is called completing the square because if we do it right, then the trinomials that we get here are perfect square trinomials. We could express them as the product of two matching factors. So now we just have to look for two numbers that have a sum of 8 and a product of 16. And the number is what we thought of before. as we went through the process is going to be 4. So we're going to have x plus 4 times x plus 4. Okay, this works because 4 plus 4 is 8, and 4 times 4 is 16. And now I have to put a plus sign between these. And I'm looking for two numbers that have a sum of -6 and a product of 9. But it should be half of the b term here. So I'm going to get y minus 3 times y minus 3. And this is equal to, now I have 16 plus 9 is 25, and 25 minus 7 is 18. But we could just use a calculator to do this sum here. So now I'm going to write this in square form. We're going to have x plus 4 squared plus y minus 3 squared is equal to 18. And then the next thing we have to know here is the equation of a circle. So what I'm thinking of, this is a formula that you definitely want to have, is that the equation of any circle can be expressed as x minus h squared plus y minus k squared equals r squared. And the center is the point hk, so the center is hk, and the radius is r. Okay, so the radius is r. So when you're identifying the center, just be careful. You want to make sure that you're taking the opposite of what's in front of the x and y. So if I have x plus 4, the coordinates of my center are going to be -4, and then comma, the coordinates, for my y coordinate is going to be the opposite of -3, which is +3. All right. A very common mistake is students will just say, oh, 4 -3. They just write what they see. But notice that it's x minus h squared plus y minus k squared. So if I had an h value of -4, x minus -4 would change to x plus 4 in the parentheses. And then for the radius, please make sure you remember to take the square root of whatever's after the equal sign. So we have the square root of 18. You can technically stop here and you will get full credit. If you want to show off, yes, you can simplify this radical, but this is only going to get you in trouble if you mess up. So if you do this part wrong, you lose credit. But if you leave it here, you get full credit. So this is not worth anything extra. But if you really want this to look nice, you could say the center is -4, 3, and the radius is 3 radical 2. But once again, you can leave your answer as square root of 18 and stop here to get 2 out of 2. Question 30, on the set of axes below, triangle ABC is drawn with vertices that have coordinates ABC given by these points here. And we want to determine and state the area of triangle ABC. So for questions like this, I think the easiest way to do these questions is to inscribe the triangle in a rectangle and then find the area of the rectangle and the resulting triangles that surround this thing. So you'll see what I mean by this in a moment. So I inscribe this in a rectangle first, and then I am going to find the area of the rectangle, and I'm going to find the area of these 3 right triangles here. And I'm going to subtract the area of the rectangle by the sum of the areas of these 3 right triangles. And that'll tell us the area of the triangle on the inside. Okay, so we're basically taking this whole area and subtracting out these 3 areas here. So what we have is we have 3 right triangles. So now we could just count the base and height of each of these. So let's say I start with this one. This goes up 1, 2, 3, 4. And it goes across 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to go across 9. Now this one here goes down 1, 2, 3, 4, 5, 6, 7, 8. And it goes across 1, 2. And then this last right triangle over here goes across 1, 2, 3, 4, 5, 6, 7. And it goes up 1, 2, 3, 4. Okay? So that's this distance over here. And you can even check. 4 plus 4 gives us 8. 7 plus 2 gives us 9. So the numbers are looking good. So what we're going to do is we're going to find the area of the rectangle. The rectangle goes 9 across and 8 down. So I could say the area of the rectangle is 9 times 8. And now I'm going to subtract the sum of these 3 triangles. And just know the area of a triangle is 1/2 base times height. The area of a rectangle is just length times width. So that's why here I just did 9 times 8. But now I'm going to find the area of these 3 triangles, add them up, and subtract it from the area of the rectangle. So we have 1/2 base times height. So let's say I start with this triangle. I'm doing 1/2 times 4 times 7. And then I have 1/2 times, let's say I find the area of this triangle. I'm doing 1/2 times 2 times 8. Now, one thing I want to point out, when you are finding the area of a triangle, the base and height should have a 90-degree angle between them. Okay, so these need a 90-degree angle between them, which all of these, or these three right triangles do have. See the 90 degrees here. So that's how I know I could use these as a base and height. So this was the first triangle, second triangle, and now the third triangle, I'm doing 1/2 times 9 times 4. Okay, so I'll say 1/2 times 4 times 9 like this. And now I just have to work this out. I can type this entire thing into the calculator, or I could do it by hand and then check my work in the calculator. So if I work this out, this is 72 minus, and now I have half of 4 is 2, and 2 times 7 is 14. And then I have plus, half of 2 cancels, and I'm left with just 8, because 1/2 times 2 is 1, 1 times 8 is 8. And then plus, half of 4 is 2, and 2 times 9 is 18. So now this works out. We have 72 minus, and if I add these two, I have 14 plus 8 is 22, and 22 plus 18 is 40. 72 minus 40 is 32. But remember, just some calculator techniques. If you want to type this in all at once, you can. It's just a little bit risky because that's a lot to type. So 1/2, I could say 0.5, and then I'm multiplying by 4 and 7 for the first part. And then plus 0.5 times 2 times 8. And then plus 0.5 times 4 times 9. And then I close the parentheses around the whole thing, and I do get 32. So our answer does check out. Question 31, in the diagram below, AE equals 15, EB is 27, AF is 20, and FC is 36. And we have to explain why EF is parallel to BC. So for this question, the converse of the side splitter theorem is the easiest way to answer this. So the side splitter theorem says that if we construct a line that is parallel to one of the sides of the triangle and it goes through the triangle, it's going to cut the two sides proportionally. So the converse is if we could show that a line divides two sides of a triangle proportionally, then that line has to be parallel to the third side. So that's what we're going to use here. So how do we show that this line divides these two sides proportionally? We just have to show that 15 over 27 is equal to 20 over 36. Okay, and for this one here, all we have to do is we could just leave this like this. We're making the statement, and this is true. Or if we want, we could reduce this. We divide the top and bottom here by 3, and we're going to get 5 over 9 equals, and if we divide this fraction top and bottom by 4, we also get 5 over 9. So this shows the first part, that line EF divides sides AB and AC proportionally. So then we could say here that EF is parallel to BC. So this explanation here is nice and simple, and it would get us full credit. We would get 1 point for showing this proportion here, and we would get another point for writing a sentence and connecting it to the idea. But before we move on, I want to look at one of the model responses so you could see another way of getting full credit. Notice that this solution, it does get full credit, but it is way more complicated than that first solution. But it will get you the points. So this strategy here involves separating these two triangles, the small triangle AEF and the big triangle ABC, and showing that the two triangles are similar. So what this student did was they showed that a pair of sides were in proportion to each other. And an angle, they started over here, A, the angle between is congruent. So once they did that, they were able to say these two triangles were similar by side angle side similarity. But then they weren't done here. To prove that these two lines or line segments here are parallel, they showed using the similar triangles that this angle here and this angle here were congruent because they're corresponding angles in similar triangles. And then finally, they were able to say that EF was parallel to BC because if you have corresponding angles congruent in this setup here, then that implies that the two line segments involved are parallel lines. So this is way more to write, but hey, it is full credit. So even if you don't find the most efficient solution, just know that there is another way to get there. So now we're moving on to the part 3 questions. There are 3 questions here, and each one is worth 4 credits. Question 32, a building is composed of a rectangular pyramid on top of a rectangular prism, as shown in the diagram below. The rectangular prism has a length of 38 feet and a width of 15 feet and a height of 22 feet. And the rectangular pyramid sits directly on top of the rectangular prism, and its height is 12 feet. Well, since the pyramid is directly on top of the rectangular prism, that means this side over here we could call 38 feet, and this side we could call 15 feet. And now for the actual question, we have an air purification filter was installed that will clean all the air in the building at a rate of 2,400 cubic feet per minute. Okay, so this rate we're going to use later. That's 2,400 cubic feet and then per minute. So this is going to be important later. And we need to determine and state how long it will take to the nearest tenth of a minute for the filter to clean the air contained in the building. So what we have to find first is the volume of the building. So the volume here is going to be equal to the volume of the rectangular prism plus the volume of the rectangular pyramid sitting on top. So for the volume of a rectangular prism, we're going to use the formula length times width times height. So first we're going to do 38 feet, and I'll just make this a little bit neater. So we have 38 feet times the width is 15 feet, and the height of the rectangular prism is 22 feet. Okay, so this is for the rectangular prism, which I'll just, abbreviate here, the rectangular prism. And now we're going to add the volume of the rectangular pyramid. Okay, so that's going next, the volume of the rectangular pyramid. And just know the volume of a pyramid like this is 1/3. So the formula for the volume of a pyramid is 1/3 capital BH. So I'm just going to write this out, 1/3 capital BH, and this is the base area. So they told us that the rectangular pyramid is directly on top of the prism. So the base area, we're just going to do 38 times 15. So it's going to be 1/3, and I'll just use parentheses for multiplying. So we have 1/3, the base area is 38 feet times 15 feet, and we are multiplying by the height of the pyramid is 12 feet. Okay, so we're just going to do all of this. Now, for this part of the test, you don't have to write the units in. You actually, don't get any credit for writing the units throughout. I personally like to write it so that we could see the cancellation later. But if this is going to bother you, like, oh no, like what if I write something wrong? Then just leave this out and just do 38 times 15 times 22, and then plus 1/3, 38 times 15 times 12. Don't write feet throughout. Okay, now this I just type in a calculator. So we're going to have 38 times 15, I'll just use parentheses for multiplying, times 22. And then plus, we have 1/3, and we're multiplying that by 38, 15, and 12. Okay, so this gives us the volume of the entire building. So the volume of the whole building is 14,820 cubic feet. Now, the reason why I like to write the units in here is that we could see how it interacts with this part over here. And where is cubic feet coming from? When we do feet times feet times feet, that's feet to the third power. Okay, but we don't say feet to the third power, we say cubic feet. So this is the volume, but then how do we get from here to the amount of time it takes to purify the air in the whole building? Well, some students might say, maybe I multiply these two, but the problem with multiplying, let me just show you why you're not going to multiply, is if you were to multiply by 2,400 cubic feet per minute, this would give you feet to the third times feet to the third is feet to the sixth power over minutes. So then the units wouldn't simplify nicely. We need to write this in terms of minutes at the end. So that's why we're not going to be multiplying, we're going to be dividing. Okay, so here we're going to divide this by, we have 2,400 cubic feet per minute. Okay, so cubic feet and then per minute. And the reason why this is working out so nicely is when we divide here, technically what's happening is we're doing keep, change, flip. We're keeping cubic feet and we're multiplying. We're changing this division to multiplication, and we are flipping to minutes over cubic feet. And the cubic feet over cubic feet is canceling. Okay. Once again, you don't have to write units in this question. If this makes you nervous, then leave it out and then just remember to divide if you just understand the concept. But if you want to see like the technical way of doing this, this is how you do this. Okay, so now we just have to do this division. So we're taking that answer. I could just press divide by and then 2,400. And this is going to give us 6.175. So we have 6.175. But remember, they told us to round to the nearest tenth of a minute. So we're just going to round this down now. To the 10th place, we have a 1. To the right is a 7. So we're going to round to 6.2 minutes. And here is our solution. Question 33, we want to prove that triangle ABC is congruent to triangle DEF. And what I want to do first is just transfer this given information over to the diagram. So they tell us we have triangle ABC and triangle DEF. And then they tell us that AB is perpendicular to BC. So I'm just going to mark this over here as a right angle. Then they tell us DE is perpendicular to EF. So I can mark this angle over here as a right angle as well. And then next they tell us that AE is congruent to DB. So I'm just going to mark these two segments as congruent. And then they tell us AC is parallel to FD. So from here, to prove that these two triangles are congruent, we're going to have to say a little bit more. So let's think about first the parallel line segments. When they tell you that two line segments are parallel, it's usually to tell you that a pair of angles are congruent. So notice what I'm tracing here, this Z shape, that it's marking this angle here A and this angle here D as alternate interior angles. And when you have parallel lines cut by a transversal, the alternate interior angles formed are congruent. So now what we have so far is two pairs of angles congruent in both of these triangles. We have the alternate interior angles, and we have these two right angles are congruent because all right angles are congruent. And then what we have next to use is these two line segments being congruent allows us to say that AB is congruent to DE. We are going to have to mention that EB is congruent to itself because technically we don't have the entire side marked as congruent in this triangle and this triangle. It's only a part here, but they overlap at EB. So we are going to be able to use the addition postulate to establish that this pair, like this side here and this side here, are congruent. So now the strategy that we're going to use, if we look at the diagram, is angle side angle. That's the postulate we want to use to prove these two triangles are congruent because we have two pairs of angles marked off and the side between the two angles is marked off. So the first angle we could establish, or pair of angles, we could say angle A is congruent to angle D. And then for the sides, we could say AB is congruent to the side in the other triangle would be DE. Okay, so these two sides are congruent. And then for the last pair of angles, I'm just going to name this angle 1 and angle 2. So I don't have to name it with 3 letters. I could just say angle 1 is congruent to angle 2. So if we can make these 3 congruent statements, then we could say these two triangles are congruent. And the first thing that you have to do with any proof is you have to establish the givens. If you don't write the givens, you're going to lose a point. If all you write is the givens, they're not going to throw you a mercy point. So it's something that you just have to write. So now we'll go through these congruent statements one at a time. So let's say first we want to establish angle A is congruent to angle D. So we'll make this statement now. Angle A is congruent to angle D. So for this one, why is this true? Well, we could say when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. So we just established that a pair of angles are congruent. So next we're going to show that the pair of sides are congruent here. So for statement 3, first we have to say something that's very obvious. We have to say that EB is congruent to itself because in the next line, we're going to use the addition postulate. So this step here, this statement reason is very necessary. And this one is true. Why is EB congruent to itself? It is true by the reflexive property. So at this point, we cannot check off that AB is congruent to DE. Now we actually have to state it over here. And we're going to use the addition postulate. The way we're using the postulate is we're going to say that AE, so this line segment plus we have EB is congruent to, and then in the other triangle, that would be DB plus BE. Okay, so when we add these two line segments, they are going to be congruent. And the reason being is we have AE is congruent to DB, that was given to us. And we said EB is congruent to itself. So when congruent parts are added to congruent parts, the sums are equal. And think about it. What do we get when we do when we do AE plus EB? That is going to give us AB. So now we could say AB is congruent to, And then if we do DB plus BE, that gives us DE. Okay, so this says now that AB is congruent to DE, and this is true by the addition postulate. Now, just know this line right here, you do not have to write this. I just prefer to write this in for instructional purposes so that you could see how we're getting AB is congruent to DE. Which parts are we adding together to build this statement up? So now we could check off the pair of sides congruent here. Now, for the last part here, to prove the last pair of angles are congruent, we can't just say that these two angles are congruent. First, we have to define angle 1 and angle 2 as right angles. So for statement 5, we're going to say angle 1 and angle 2 are right angles. And the reason behind this, we could say perpendicular lines form right angles. And now that we've established that angle 1 and angle 2 are right angles, we could say that they're congruent because all right angles are congruent. So we just established our last statement of congruence that we need. So we're finally able to write the proof statement here. These two triangles are congruent by angle side angle. Question 34, in the diagram below, a boat at point A is traveling toward the most powerful waterfall in North America, the Horseshoe Falls. The Horseshoe Falls has a vertical drop of 188 feet. The angle of elevation from point A to the top of the waterfall is 15 degrees. After the boat travels toward the falls, the angle of elevation at point B to the top of the waterfall is 23 degrees. So I'm just going to label this one here as 23 degrees. And then we need to determine and state to the nearest foot the distance the boat traveled from point A to point B. So if we're looking for the distance the boat travels from point A to point B, I'll put an X over here. We're going to solve for this value here, X. And then I'm going to label this distance over here Y, and then the whole thing here I'm just going to call Z. Okay, so this distance over here, I'm just going to name this whole distance as Z. So what we have then, I'm going to draw two separate right triangles. I'm going to draw the big right triangle, and I'm going to draw the little right triangle. So the little right triangle is going to go over here. And what we have is the big right triangle, this angle is 15 degrees. The entire distance, I'm just going to call Z. And then the vertical component is going to be 188 for the 188 feet. And then the little triangle here, this angle is 23 degrees. And this distance over here is Y. And then this one here is 188. Okay, so that is how I'm going to label these two diagrams here. And then basically what we're doing is we have X plus Y is equal to Z. So if we're looking for the distance the boat travels from point A to point B, that's X, then I just have to find Z minus Y. Okay, so I'm going to find the length of this side, the length of this side, and then subtract the two. That's basically what we're going to do here. So for this one, we're going to need trig. So remember from before, SOHCAHTOA. And what we have for both of these is we're going to be using the tangent function, because if I know this angle is 15, this angle here is opposite of the 15. And then this side here is adjacent. And then same thing with this triangle over here. This right triangle, this side is opposite, and this one is adjacent. So I'm going to use the tangent function. We're going to have tangent of 15 degrees is equal to the side opposite is 188 over the adjacent side is Z. And then from here, if you just know to do the swap, then you could say Z equals 188 over this, or you could do the algebra, you could cross multiply, and you could say Z times tangent of 15 degrees equals 188 times 1 is 188. And then from here, I just divide both sides by tangent of 15. So I'm going to go divide by tangent of 15 degrees. Okay, and then the rest I'm going to write in the calculator, but I'll solve this one also so that I could do this all at once in the calculator. So Z right now is equal to 188 over tangent of 15 degrees. And now for the next triangle here, I'm going to say tangent of 23 degrees is equal to the ratio of the side opposite is 188, and the side adjacent to the 23 degree angle is Y. And now from here, I could cross multiply the same way I did over here, and I'm going to get Y times tangent of 23 degrees is equal to 188. And now just divide both sides by tangent of 23 degrees. And that's going to tell us what Y is. But remember, once I solve for Y and I solve for Z, I'm just going to subtract the two, and that's going to tell us what the distance is from point A to point B. So I'm going to have here y is going to be equal to 188 over tangent of 23 degrees. So I'll type these in one at a time. We have 188 divided by tangent of 15 degrees, okay, is here. And then we have 188 over tangent of 23 degrees. So 188 divided by tangent of 23 is going to give us this. Now, ultimately, we're going to be rounding our answer to the nearest foot. So what I'm going to do is I'm going to chop this at a few decimal places first. So I'm going to chop this at, let's say, the thousandths place. So I'll say 701.626. I'll round this one too. So in the thousandths place, we have a 5. To the right is a 5. We're going to round up to 6.626. And then here in the thousandths place, we have a 0. To the right is a 2. So this one is really, we're going to be subtracting 442.9. If I put the 2 zeros here, it doesn't matter, but this will be fine. So to the nearest foot, this is going to be 259 feet. So now I'll just write out what we had on the calculator screen. So we have z equals 188 over tangent 15 is 701. And like I said, I'm going to round this to the thousandths place first, and then at the end, I'll round to the nearest foot. So we have 701.626. And then for y is equal to, we have 442 and then 0.900 like this. And then now, remember what I did before, or I mentioned before, that we're looking for the distance from A to B, which is x. So if x plus y equals z, then x is equal to z minus y. So that's why here we're just going to subtract z minus y. We're going to do 701.626 minus 442.900. And this works out to, we're going to have here 258.726. So now we could write our final answer. So now to the nearest foot, we're going to round this. We look to the ones place is an 8. To the right is a 7. So we're going to round this up to 259 feet. And here is our solution. So now moving on to part 4, the final question. And this question here is worth 6 credits. Question 35, triangle Joe has vertices whose coordinates are J 4, 6, O negative 2, 4, and E 6, 0. And we have to prove that triangle Joe is isosceles. And I definitely want to use the set of axes on the next page. So I just copy and pasted the question onto the second page, but first I'm going to plot these points. So now that we have these plotted and connected, what I'm going to do is I'm going to use the graph to find the length of the two sides that are equal in measure. Now, I think it's visually obvious here that these two sides are equal in measure, JO and JE. So those are the two sides I'm going to target. So I'm going to use the rise over run method. I'm going to go up 1, 2, and I'm going to go over 1, 2, 3, 4, 5, 6. So what I'm basically doing here is building a right triangle to get from one point to the next. And this triangle here, the right triangle, has legs that are 2 units long and 6 units long. So to find the length of the hypotenuse, I could say here that JO is equal to the square root of 2 squared plus 6 squared. I'm basically using the Pythagorean theorem. So we could say that JO squared is equal to 2 squared plus 6 squared. And now I just solve for the length of JO is going to be equal to 2 squared is 4 plus 6 squared is 36, and 4 plus 36 is 40. So then we just take the square root of both sides, and we get JO is equal to the square root of 40. We do not actually have to simplify radicals in this part of the test. If you do and you do it wrong, you're going to lose a point. So you're better off just leaving it as is. Unless they say write the distance in simplest radical form, you don't have to. So now to get from J to E, I'm going over 2, and I'm going down 1, 2, 3, 4, 5, 6. Okay, so this is going to give me another right triangle where the dimensions here are 2 and 6. And this triangle is going to be congruent to this one. So I just know right away JE is also going to be square root of 40. But if I want to show the work, I could say JE squared is equal to 2 squared plus 6 squared. And now for this part, I have JE squared is equal to 40. So that tells us then that after we take the square root of both sides, that JE is also equal to the square root of 40. And now I'm just going to transfer this work back to the first page. So now I'll just make the commentary here that these two sides are equal. And I'll do this with like a bit of a flow chart type of representation. So I'm going to say that these two sides here are equal, and then say that this implies then that JO is congruent to JE. Okay, since the two sides here are equal in measure, that's going to tell us then that JO is congruent to JE. So now we have enough information to prove that triangle JO is isosceles. We could say that this triangle is isosceles because it has two sides congruent. Now, just know you can find the length of the third side, but if you want to show that the triangle is isosceles, you only have to establish that two sides are congruent. So we can stop here. And once we finish writing the sentence, we are good on the first page. So now for the last part of question 35, we have y is located at 2, 2. So I'm just going to label this point over here as point y. And they're saying point y is on line segment OE, which we could see that it is. And then what we need to do here is prove that JY, so now I'm going to connect these two. We need to prove that JY is the perpendicular bisector of OE. So in order to show that this is a perpendicular bisector, we need to show that JY passes through the midpoint of OE, and we need to show that JY is perpendicular to OE. So first, I'll find the midpoint of line segment OE, and I'll use this notation here. And to find the midpoint, what I'm going to do is I'm going to take the coordinates here of O and E. So the coordinates of O and E, we have the point here is negative 2, 4. And the point for E is 6, 0. And what I'm going to do is I'm going to take the X coordinates, I'm going to add them and divide by 2. So I'm just using the midpoint formula here. The midpoint formula says x1 plus x2 divided by 2. So I'm going to add, I'll call this x1, y1, and I'll call this one x2, y2. So I'm doing x1 plus x2 divided by 2. So that's negative 2 plus 6 divided by 2. And then we have comma, y1 plus y2 divided by 2. So 4 plus 0 divided by 2. And then this tells us here that the midpoint of line segment OE is located at 4 divided by 2 is 2, comma, and then 4 plus 0 is 4 divided by 2 is also 2. So this is looking good. This is showing that y is the midpoint of line segment OE. And then the next thing we need to show is that these line segments here are actually perpendicular. So I'm going to find the slope of JY. And the slope of JY I could find by using y2 minus y1 over x2 minus x1. So the point here for y is 2, 2. And the point here for J is located at 4, 6. So if I want to use the slope formula for this, I can. I'm going to do 6 minus 2. So I'm doing the difference of the y values over the difference of the x values. And this gives us 4 divided by 2, which is equal to 2. And then I'm going to find the slope of OE. So the slope of line segment OE is equal to, and for this, I'm doing the difference of the y values. So I'm doing 4 minus 0. I could also do 0 minus 4. It doesn't matter. Sure, I'll do y2 minus y1 so it matches the formula. So 0 minus 4 divided by, and then I have 6 minus negative 2. And for this one, I get 0 minus 4 is negative 4 over 6 plus 2 this turns into is positive 8. And then this simplifies to negative 1/2. And now for this part, I'll do kind of a flowchart type proof here or explanation. I'm going to show here with the flowchart that 2 and negative 1/2, they are opposite reciprocals. Okay, so these are opposite reciprocals. And I'm only doing this so that I don't have to write out a ton of sentences. This just saves a lot of space. So these are opposite reciprocals. And then what does that tell us? That tells us then that JY is perpendicular to OE. Okay, so JY is perpendicular to OE. So we now have enough information to write this proof. We could say JY is the perpendicular bisector of OE because Y is the midpoint of OE and JY is perpendicular to OE.